going on, guys? Let's do this problem doing by scalar method. In this case, the question is asking determine the support tree extension at the fixed support point A. So let's see how we can do this using scalar method. So to do that, so first I point the forces here. So we are going to have f of c in this direction, f of x in this direction, also uh, f of y in this direction, right? So this is the direction f of y, and these are the three forces we have to find. So let's see how we can find it. So first of all, we have two forces given, that's 400 and 200. We know that 200 is straightforward, that's acting in the f of x, so that's straightforward, but we have to calculate the other forces. So let's see how we can do this. So in this case, 400. So 400 is given. So to calculate this one, so to calculate the y-axis, what I had to do is I had to take the cos theta, because if you see the angle, this is going to be the theta, and it's coming a little bit downside and going along the y-axis, right? If I calculate this cos theta, it will give the force along y-axis. So let's calculate. Let's call this f1. Therefore, it's going to be 400. Let's call it 400 times 400 times cos theta is going to be adjacent over hypotenuse, so it's going to be 4 over 5. And if I calculate, this comes out to be, so 80 times 4 is going to be 320, and this is pounds, right? Pounds. And if I calculate the other one, so let's say the y-axis is c-axis f2. So if I take c-axis, that's going to be sine theta, because sine theta, because it's going down. Sine theta, then sine theta is going to be opposite over adjacent. Opposite is 3, opposite over hypotenuse, so it's hypotenuse is 5, so it's 3 over 5. Then this is going to be 80 times 3, 240. 40 pounds. Let's redraw the diagram. So if I redraw the diagram, it's going to be something like this. So we are going to have something like this. So we know this. So this is my y-axis. So y-axis is along this way, so it's going to be acting straight toward like this. So it's 320, and we calculated the c-axis. If it's acting downside, so it's going to be straight down. That's going to be 240 lb, and also we know 200 is acting on the x-axis. 200 is acting on the x-axis. So now we can calculate the fx, fy, fc. So if I take sigma f of x, and it's 0 in statics, so if I solve for this one, I will get, so I have to respect the xyz that's given in the diagram. So if something go against it, it's going to be negative. If something go along with that, it's going to be positive. So in this case, fx is positive, because along the x-axis, I took the direction along the x-axis, so it's going to be positive. And then we have another f of x, it's 200 right here. 200 is going along the x-axis, so it's going to be positive. Positive 200 equal to 0. And fy is positive. I took along the y-axis, so it's going to be positive. And also we found out that 400 going 320 going along the y-axis, so it's going to be positive. So positive 320 is equal to 0. fc is going to be, this upside is positive, right? So this is positive, so sigma fy equal to 0, sigma fc is equal to 0. So fc, and if you see, it's going downside, the force is acting downside, therefore it's going to be negative 240 equal to 0. Therefore if I solve this one, I will get f of x is equal to minus 200, and fy is equal to minus 320, and Fc is equal to 240 pounds. So these are the three forces we have. Now we have to calculate the moment around these things. So let's call this is mz. So I'm taking a counterclockwise positive for everything. So this is mx counterclockwise positive, fc counterclockwise positive. So if I do this one and create equation, so let's create for sigma mx moment around x. So if I take that one, mx is going to be positive because I'm taking the counterclockwise positive. So this is 0 in statics, and mx is going to be positive. Then we have 240. So 240, pushing this object down. So it's meant clockwise. So that means and also one more thing to remember, for x and y axis, z is the only one that's going to create moment, not y or anything. So in this case, we know this is creating 240 from here. So let's redraw this one here. So this is my 240. This is 320. So 240 pushing this object down, so it's going to be negative 240. So we are taking movement around x, so we have to take the y distance, so it's going to be 6. So times 6 is going to give us, so 6 is equal to 0. Then if I solve for this one, this one comes out to be mx equal to 1440 foot pounds. Then if I take y-axis, as I mentioned before, for the x and y, z is the only one that's going to create movement. Therefore, we only take z. So this my is positive, and since so I have to look at c. So for the y, still pushing the object down, so it's going to be counterclockwise. So it's going to be negative 240 times, in this case this is y-axis, the distance from y is 2 feet, so it's going to be multiplied by 2, which is equal to 0. Then if I solve for this one, my comes out to be 480 foot pounds. Then if I solve for mz, but for the mz we are going to have two forces. X is going to create moment, and also y is going to create moment. So in this case, so if I take this one, I will get mz minus 200 because it's pushing this object clockwise, so it's going to be minus 200 times the distance is 6 feet. If you see, from z is 6 feet, so it's going to be times 6, and also other one 320 also pushing this object in the clockwise direction, so it's going to be negative 320, and the distance is 2 feet from the origin, so it's going to be multiplied by 2 equal to 0. And if I solve for this one, mc minus 1200 minus 640 equal to 0. Therefore, the final answer comes out to be mc is equal to 1840 foot pounds. And that's how it's done. So we have found mx, my, mz. And that's all about it. I hope you guys like this video. See you next time.